You came back for part B. Glad to see that. Okay, here we had our problem. We had 2 parentheses 2x plus 3 plus x having equal 2x plus 12. Well, this is the problem we were going to try to solve at the end of the last video. I said, nope, got to come back for part B. This is part B. What I'm going to do is I'm going to go ahead and use the pieces so I don't have to try to hand draw those all the time, maybe save myself some time. And I'm going to set up this problem. But here's the thing I want you to notice. I'm also going to do it again by hand using the algebraic notation. So we have the original problem in both cases. Let me shrink that one a little bit. Let me increase the size of this one a little bit. Okay. So now, when we did it before, if I had something like this 2 of the 2x plus 3s, I would bring down 2 x's and a 3, and then I'd have to do another set of 2 x's and a 3. And then I'd have another x. And then I would have the 2 x's. And because we were using the pieces, I couldn't put a 12 in there. I had to bring it down as a 10 and a 2. So that works out. So there's our problem. Now, algebraically, I want to do that exact same thing. I want to get it cleaned up so I know what I have. Well, when I look at it, I've got 2 of these 2 x's, which means I've got 4 x's right there. And I've got 2 of these 3's that are being added. Well, 2 3's is a 6. Plus I have another x. Well, altogether I've got 5 x's and a 6. So all I've done is take this side here on my left, over here on my left, and all I've done there is I've cleaned it up, reduced it down to make it look prettier. Well, now if I actually think about it, and I look at what I have over here, I have 1, 2, 3, 4, 5 x's, and 3 and 3 gives me 6, and then I got 2 x's and the 12 on the other side. So all I've done in this first step is kind of clean it up and reduce it just so I can see how many of everything I've got. Now, what's the next thing I would do? Well, I would try to get rid of these 2 guys right here, right? But if I had to do it on this side, I'm going to do it on the other side too. So what I'm doing is I'm taking 2 stars or 2 x's away from both sides. So the symbol that we might use is like this to do it. Over here it means I'm going to subtract 2x. I'm subtracting. Remember, every step I'm going to draw that horizontal line. Now when I do that up here, really what I'm doing is I'm canceling off these 2 and I'm canceling off these 2. That's what these steps are doing when I put this arrow part in there. I'm taking away 2 x's from both sides. Now let's see what I have left. On the left here, I've got 1 and the 3. Whoops. I got 1, 2, 3 x's all by themselves. And then I got the 2 3's. Okay. On the other side, I've got the 10 and the 2. I have that. Now, if I do it up here, 5x take away 2x. 5 minus 2 is 3. I got 3 x's and the 6. On the other side, the x's completely cancel. I'm just left with the 12. So now, my next step would be to get rid of these 3's. Well, the way to get rid of those 3's is if I brought in the opposite of those 3's, and that's if I brought in some of these green 3's. But if I add 2 green 3's to that side, I've got to add 2 green 3's to this side. That's what I would have to do. Well, what are the green 3's? The green 3's are negative 3's, so I've really subtracted, or I've added a negative 6 to both sides. Or you can think of it as I subtracted 6 from both sides. So now when I do that, I'm left with 3 stars, or 3 x's I mean, on this side. And on the other side, these have all canceled out. They're gone. And I've got to take away 6 from this. Well, this 10, I can take away 6 and leave 4. So now I have a 4 to go with my 2. So I've got these 3 x's having equal 6. Well, here I would say that, you know, the old x equaled 2. over here, I got to do the same thing. So I got 3 x's left on this side because the 6 and the negative 6 cancel out. And I've got a 6 left over. Well, now I'm trying to figure out how I got 3 of these x's going into 6. Well, the way to get rid of the 3 is to divide it off. I've got x equals 2. So I'm doing the same thing. I'm subtracting or I'm adding to both sides the same way. So now let's go through and let's check our answer and make sure that we got the right answer. Ooh, that really jumped back up. Okay, so here's our problem. And if I do it the old way, I'd have to have 2 plus 2 plus 3 and 2 plus 2 plus 3. That's the stuff in the parentheses, plus a 2, and then I'd have to have a 2 plus 2 plus 12. 2 plus 2 plus 3 is 7, and 7 gives me 14 in the parentheses, add a 2, that gets me 16. 2 plus 2 is 4, plus 12 is 16. 16 equals 16, that works out. So my triangle, my x, is a 2. Now if I do it mathematically, 2 parentheses 2 times 2 plus 3 plus 2, should change colors on that. Let me change colors on that. And then on the other side, I've got 2 times 2 plus 12. Okay, this gets me 7. 2 times 7 plus 2. 2 times 7 is 14. Plus 2 gives me 16. 2 times 2 is 4. Plus 12 gets me 16. Both sides equal 16. So my x equals 2. So we can go ahead and do the same things. When we got all our stuff together and we rearranged it and set it up, we ended up just simplifying our equation. So this simplification step over here, I'm going to get to this magic pen. This simplification step right in here, this is important when we're doing it by hand and we're trying to figure out what happens. I have 2 of the 2x plus 3, which means I have 2 and 2x and 2x, which gives me a total of 4 x's. You saw that with the pegs. If I had 2 3's, I had a 6. Then, when I noticed that I had a 4x in the next, that gave me a total of 5. Algebraically speaking, we said that's combining like terms. We did a distributive property and we combined it like terms. What does that mean for us? It means we're just trying to get it cleaned up a little bit, get everything organized. Okay, so now, here's a new type of problem. I got 4x plus 2 times the negative x plus 3 equaling x plus 5. How are we going to solve this? Well, that's real simple. You're going to come back and see me do it in part 6, or part C. So come back for the next question.